Flip back in your notes. So what we did before 9-1. Remember we cut out those little shapes? How did we rotate our shape? You guys are so talkative today. What? On the introduction lesson that we did, like on Tuesday, we cut those shapes out of those note cards. How did we rotate our note card shape? What did we do with it to rotate it? Reflection, we flipped it. Translation, we just moved it, or we split it over. How do we do a rotation? So rotation. Yeah, we move it, kind of rotate it, we turn it, so it can go upside down, it can be on its side. Good, so Mr. Klon is rotating quadrant 1 there for us. And that one's a nice rotation, it's symmetric, so we're going to talk about that next week. All right, so rotation means to like turn on its side, or to turn over, or to turn an object around a point. So turn an object around a point. Seeing a couple of people with their laptops open, if you can just really try to focus hard on this, that'd be great.
And if you look at the keyword here, it's not just rotation, it's an object moving around a point. So just like your clock, there's a point in the middle, so you are rotating around that point in the middle.
Good. What does the Earth rotate around? What's the main point of our solar system? Yeah, the sun. Good. So that's the thing, is we have to rotate. And our main point in a graph that we're going to rotate around is probably what? What's the middle of our graph? Yeah, the 0, 0. What do we call that 0, 0? Origin. So we're going to be rotating around the origin today. Eventually, if you continue to study math, you would figure out how to do rotations around other random points on the graph. When we do just the origin, we can follow some rules, and this is just kind of our basic intro today to see how rotations look, how we can visualize them, start seeing them, things like that. So first off, we have this clock, and in math it's really important when we rotate, we have to talk about things as clockwise or counterclockwise. Okay, and this is the part that, I don't know, maybe let's use 2 colors. That'd be a good idea. Miss Merrill, you're a genius. All right, use blue. I'm going to use blue and orange. If you want to grab 2 colors from your bins, that might help you realize what's happening here. So we're going to go in 2 different directions. All right, so first off, when you look at that word counterclockwise, what is our base of counterclockwise? What's the base of the word counterclockwise? There's kind of a prefix and then a base word. Cool. I don't know what I'm asking. I'm just trying. We got clockwise. So with clockwise means to go the normal way around the clock. So normally when we read a clock, if you start at noon, where would you go after noon? 1 o'clock, and then 2 o'clock, 3 o'clock, 4 o'clock. You'd go this direction. So this is our clockwise. All right, when we see that word counter, what does it mean to counter someone? Blocking, yeah. So if you put in an offer on a house, and then somebody gives you a counter offer, that means that they're giving you a different offer and they're trying to kind of negotiate with you. So counter is kind of another word, if you heard Mr. Kwan say it, is anti. Mr. Kwan, is that how it's talked about in the Asian country, like anti-clockwise? Good. Okay, interesting. So some of you might have heard that as anti-clockwise, but anti-clockwise or counterclockwise means we're going to go in the other direction. So we're going to start at noon or 12 or midnight and work our way backwards. So go 12, 11, 10, 9, 8. Go in that other direction. So clockwise is our normal. Counterclockwise is our opposite.
And if you think about the word counter, it can also mean to reflect. So when you did your reflections, you're basically moving it the other way.
All right, so for this first one, we have a rotation, and we're going to go 90 degrees counterclockwise. So big thing here is we're going to go counterclockwise. So this one we're going to go to the right or to the left? Good, to the left. Left is counterclockwise, right is counterclockwise. It gets confusing, though, to use left and rights, because once you're at this point, technically you're going right for counter, and then you're going left. I don't know. It turns into a whole thing. Depends on how you're looking at it. So we have our 90 degrees. Oh, I forgot something. I'm sorry. We're just getting ahead of myself. I got really nervous about the counterclockwise and clockwise thing. All right, so if I'm going counterclockwise, and I start at the top of something, that would be our 0 degrees. And then as I rotate, if I rotate halfway around a circle, how many degrees is halfway around the circle? 180. And then if I rotate all the way back to the top, how many degrees? It'll be another 180. Altogether, that would be 360. These are kind of our cardinal ideas where we're thinking. So if I start at 0 degrees, but I only go halfway to 180, I stop halfway in the middle. What do we got for that? Good, 90. And what about if I stop at 180, and now between 180 and 360 I make a halfway point? This one's a little harder to remember. I think it's each of those corners is 90, so it would be 180 with another 90. Oh. So if I go 180 and then another 90 to 270, yeah. Does that make sense? Feeling it? Okay, but if I do clockwise, our normal one, and I go in the other direction, I still start at 0. That's fine. But as I go this direction, how many degrees have I now turned? 90. So it's either 90 degrees clockwise. I'll do CW for clockwise, how about? But it's 270 if we do counterclockwise. Counterclockwise.
It's like you've taught this.
Have I? I haven't taught this part before.
Oh, really?
Yeah, this is new for me. Normally we only teach counterclockwise. If I go another 90, where do I end up at? 180. Does it matter if I go clockwise or counterclockwise for 180? No, if I tell you just to turn around, does it matter which way you turn around? No, you end up facing the same direction. So it doesn't matter counterclockwise or clockwise for that 180. But if I keep going, this 90 degrees that was counterclockwise is now what in clockwise? Yeah, 270, nice and black. So it's 270 clockwise, 90 degrees counterclockwise. Next year I'll have this better as a graphic. Thank you for being patient with me. All right, and then 90 degrees back to 0 would be 360. Good. Okay, and with 360, again, does it matter if you go counterclockwise or clockwise? No, if I just tell you to do a full circle, you're going to end up at the same spot. Doesn't matter which way you go. Okay? All right, here we go. Now we're ready for our examples. Now we're grooving. We're jiving. All right, 90 degrees counterclockwise. So 90 degrees counterclockwise means I'm going to move to the left 90 degrees, or move kind of, towards that left, towards that window. Okay, and if we think about quadrants, 90 degrees is really just moving one quadrant over. So as I move this W is currently in quadrant 1. If I move it over, which quadrant should it end up in? Quadrant 2. Point Z is in quadrant 4. Where would that move to? It's going to move this way? Yeah, it's actually going to move it's going to move like up, because it's all kind of like this circle. It's going in this direction. All right, so we have a rule here that helps us visualize that. And some people, they're really visual with this. They can just kind of see that rotation off the bat. I don't know how they do it. Okay, our 90 degrees clockwise. Oh, nope, it was counterclockwise. Miss Morrell. Sorry, this clockwise and counterclockwise business is making me real nervous. All right, 90 degrees counterclockwise. Our rule is that XY is going to change to opposite Y, X. All right, so what that means is when I look at these, I already found the ordered pairs for this. Okay, but now if I find our new ordered pairs, I'm going to go to W prime. I'm going to start with my Y ordered pair, my Y coordinate. My Y is the second number, and I want to do opposite of the second number. So what's opposite of 1? Negative 1. And then I want my X to be the next point. So what's my X coordinate? 1. All right, that one's a little goofy because it ends up being the same number. So X prime we'll see here, a little bit different. So I'm going to start with opposite Y. So what is my Y? 3. And what's opposite of 3? Negative 3. And then I want to keep my X, which is 2. Okay, Y prime. We have is 5, 0. So I'm going to start with my Y. My Y is 0, but I need to do opposite. What's the opposite of 0? Nothing, it's just 0. So 0, 5. All right, Z prime. Should have spaced these out maybe a little bit more. So many notes for myself for next year. I have 3, negative 1. So we start with our Y. Which number is the Y? 3 or negative 1? Negative 1. And this is a negative, so if I think negative, negative 1, what's really negative, negative 1? Positive 1. That's why I like to think about it as opposite, because negative, negative, it gets my brain like, what? And then 3. All right, so then we're ready to plot those points. So we have negative 1, 1. So from our origin, we're going to go left 1, up 1. For X prime, we have negative 3, positive 2. So left 3, up 2. All right, Y prime, we have 0, 5. That one's a little trickier. Is 0, 5 going to be right 5 or up 5? Good, up 5. You're on it today. And that's our Y. Oops, I forgot to label this one W. All right, and then our last one is Z. Z is 1, 3. So right 1, up 3. All right, and then go ahead and connect those if you have that ruler. That might help to make that nice and neat. All right, so rotate it around that origin 90 degrees. We're going to try and do the next ones a little bit quicker because just to get you guys going on your practice. But like I said, Monday we'll do a little bit of review and then the rest will be to get caught up on homework. So, all right, if I take this is just like a see-through. I made it based on this. So if I take this and match up my origin, that's my point where I'm rotating. So I'm going to keep that point exactly where it is. This doesn't match up exactly as it did last year, but if I rotate it, did it end up at that point? Yeah. It doesn't matter. I didn't make a new copy this year, so I must have changed the size a little bit from last year to this year, but yeah, when I rotate it, it ends up 90 degrees, about right where it is. All right, so our 90 degree counterclockwise is this rule, but what's the same thing as 90 degrees counterclockwise? This 90 degrees is counterclockwise. 270, but it would be 270 degrees what part? Clockwise. Okay, so if you color-coded this, if you want to color-code this part, so 90 degrees was my counterclockwise, and 270 degrees clockwise. All right, these next ones go a little bit quicker because they're triangles, so they're less points, but also the next one's really easy. The last one's a little bit more confusing. All right, the middle one, we're going to rotate 180 degrees about the origin. 180 degrees. This one doesn't tell us to go counterclockwise or clockwise. Why? Good, it's the same for both. So our 180 degrees is for both counterclockwise or counterclockwise. It can be both. All right, and our rule tells us that we're going to take our original XY ordered pair and we're going to make it opposite X, opposite Y. So pretty much we're just taking the ordered pair. We're not going to switch the order. We're just flipping it from negatives to positives or positives to negatives. So keep it the same order. Just switch from positive, negative, negative, positive. So for W prime, instead of negative 1, we're going to do positive 1. Instead of positive 1, negative 1. X prime, instead of negative 2, 3, positive 2, negative 3. And Y prime, instead of negative 4, negative 2, positive 4, positive 2. And once we have those points, we just plot them on our graph. Okay, if you want to work ahead and try and plot those, make sure you get them right. That's going to be another part of today is on Alex, making sure that you plot your points correctly. So that's why we did so much of that practice at the beginning of this week. 1, negative 1, right, 1, down 1. That's our W prime. X prime is 2, negative 3. So right 2, down 3. And Y prime is 4, 2. So right 4, up 2. So if we think of 180 around the origin, how many quadrants would we be going? So if I start in any quadrant and I have to go 180 degrees around my origin, how many quadrants do I need to travel? 2, yeah. So X starts in quadrant 2. It starts up here. And then how many does it travel over? 1, 2. Or it could go 1, 2. W goes over 1, 2. Y goes over 1, 2. Good. And again, I have that printed out for us so you can kind of see that over the top. Again, it's a different size. So if you want to see that visual of actual rotating, this is going to be on Alex where you get to actually maneuver it like this. If I have that 180, this would be on my 90. And then 180. It matches up relatively. Again, I printed it a different size last year, so it's a little off. How are you feeling? Decent? Okay. All right, I'm going to show you my little hack that I do for these. And again, as you do them, you might find there's a couple hacks for them. I don't know if hack is even the right word. It makes it a little easier, but probably not super easier. There's a couple hacks for these. This one, we're going to do 270 counterclockwise. To 270 degrees counterclockwise. Or, what does 270 degrees match with if we go clockwise? 90 degrees. So again, I'm just going to color code that. I think Alex, the more I think about those practice problems I looked at, I think they always use 90 degrees. They never go with the 270. So either it'll be 90 degrees counterclockwise or 90 degrees clockwise. Thank you. All right, so our counterclockwise 270 or 90 degrees clockwise means we're going to move it over. If I go clockwise, it's going to go from this kind of bottom right to the bottom left. And this Y up here would go from the top right to the bottom right. We're moving this way 90 degrees. Or we could think that we're traveling 3 over in the other direction. And our rule is X, Y switches to Y opposite X. All right, so as I look at this with X prime, Y prime, and Z prime, this is my hack, is I do all 3 points at the same time. It goes a little bit faster for me. Okay, if it doesn't go faster for you, don't do it. It's not a hack then. Okay, but if it goes faster for you, do it that way. So when I do this, the reason why I do this is because I'm going to start with my Y's. And when I list my ordered pairs here, it's easy for me to remember Y's are which numbers, the first numbers or the second numbers? Second numbers. So I just color up my first numbers and I say, oh, those are my numbers I'm starting with. -2, 1, -3. And then for my next number, I'm going to look at my X's. But as I do my X's, I want to do opposite. So I'm going to cover up those Y's. Here are my X's, but I want to make sure I do opposite of them. So 4 would go to -4. 3 goes to -3. And 3 goes to -3. That's a little bit easier for me to think about. Personally, I don't know why, rather than thinking like, okay, Y first. Which one's my Y? Okay, write that down. Now go to my X. What's my opposite of my X? It's easier for me to just look and see if I have these all listed already, make those Y's, throw them there, and then do my opposite of my X's. All right, last step is just to graph them. So -2, -4, left 2, down 4. Y prime, we have 1, -3, so right 1, down 3. Right? Why doesn't that look right? That's right. Z prime is -3, -3, so left 3, down 3. And remember, as we do these rotations, reflections, translations, our shape shouldn't change size, and it shouldn't change how it looks. All right, real quick for that that idea of the rotation, if that helps you to visualize, for 270, if I go counterclockwise, I'm going to turn to the left. It'd be here's 90, 180, 270. If I go one more, I'm back to my 360. Okay, so that was at 270. The other way is going the other way, which I just did, and that's just 90 that way. So two ways to think about it. You can go the long way, 90, 180, 270, or you can go the short way, which is just going from 360 to 90. I think Alex always does the short way. They always go to that 90. All right, you have the rest of the time today to work on your Alex assignment.